Vector addition and scalar multiplication. So if we have these two vectors, u1, u2 is u, v1, v2 is v, and then let's say that we have k, which is just a real number, which is also known as scalar. Scalar is another word for just a normal number.
Just any number you can think of.
Compared to us talking about a vector, which has two components.
Right.
Okay, so we can do two things basically in this section. We can do vector addition, so the sum, also known as the resultant of the vectors. You simply add the x components and the y components, and then your answer is a vector.
Okay.
The product.
So that's like head plus tail, head thing.
Yeah, it's like adding them together, head plus tail.
So
if we have two vectors and we're putting them together, we do add them. And we'll look down here at the bottom at what is visually going on here in a second.
That sounds great.
Okay, so the product of the scalar k, so if we have some number and we're timesing it into vector u, it's just like a distributive property kind of thing. You multiply the k times the x component and the k times the y
It's really
component.
similar to what you've done before with a matrix. If there's a number right in front of that matrix, a scalar, you multiply with every number inside the matrix, and it's a similar situation here.
Indeed, it is similar. So here we've got these two vectors, u and v. They want us to find the following things. So the first thing is u plus v. So we would add our x components and our y components.
Now, is order important when you add these guys?
Well, you could do 4 plus a negative 1. That's fine because addition is commutative.
Right.
So you can do it in any order.
All right.
But you do need your x components to be first and your y components
That
to be
is correct.
second.
Yes.
That's
what
standard.
Right.
Thingamajigger 3, 10.
Standard thingamajigger.
Whenever we look at this visually, so down here, geometrically representing this, our first vector, negative 1, 3, is this in red on my screen, which has the long dashes. The second vector, what we would do to add it to this first one is we'd actually stick its first point at the end of the first vector.
So the tail at the head.
Yeah, you stick the tail of the second vector at the head of the first vector, and then you draw out that vector, which was 4, 7. So write 4 up 7. And so the resultant vector, so the result of this addition, is the line from the very first start to the very last end.
That bright green guy.
And if you look, this really is 3, 10, that vector, which is what we got.
Look at that.
Next.
Who knew?
3 times u. So 3 times our vector for u, which is negative 1, 3. It just distributes in, so that's
negative 3 times 9. Just 3 times all those things. Bless
3,
you.
9. Okay, so, and geometrically, here's what's going on. We start off with the vector negative 1, 3, and what we're doing is we are multiplying the length of it by 3.
So we would have 3 of those, right?
Right, so yeah, we could have drawn it slightly different where, look, we've got 3 of these vectors added onto each other.
Son of a gun, that's cool.
Okay, now this is where it gets a little complicated. 2u minus v.
I don't see any complications there. We're just combining the first two things we did.
Geometrically, it gets kind of complicated.
Oh, more geometric complications.
2 times u minus v. Now, one thing you need to understand, well, you don't need to understand it, but I'm just going to throw this out here, is that technically there's no such thing as subtracting vectors. What you do is you add and distribute a negative 1. Okay, we have vector addition. We don't really have vector subtraction. You multiply through with negative 1, and then you add the 2 vectors together. It's just like one of those mathematical technicalities. Really, subtraction doesn't exist. We're always just adding a negative.
Who are you? Subtraction doesn't exist. You can add, subtract, multiply, divide.
Sorry, this was a tangent that I didn't really mean to get us off on.
Okay,
so I just distributed the 2, distributed a negative 1. Now I need to add these vectors together. So that's going to be negative 2 plus a negative 4, which is negative 6. 6 plus a negative 7, which is negative 1. So this is our end vector. So geometrically, here's what's going on. We've got u, which is in purple here on my screen. We're multiplying it by 2, which gets it to here. So that's this vector. Then if on top of that you were to put 4, 7, that would go this way. What multiplying by a negative does is it makes it go the exact opposite direction. So from the green, we go orange, and so our resultant vector is this black one down here.
Which matches what the math says.
Yes. So that's how we roll with vector addition and scalar multiplication.